The James Webb Space Telescope, JWST, is a large infrared-optimized space telescope launched in 2021 by NASA in collaboration with the European and Canadian space agencies. Aside from being the largest, it is also the most powerful space telescope ever built. It is capable of observing some of the earliest galaxies in the universe and studying the formation of stars and planets. Since its launch, the JWST has established itself as the most advanced space observatory in the world. Although the JWST is not specifically designed to study individual planets, it recently captured the most detailed image of Pluto ever taken. This achievement was made possible by the telescope's infrared capabilities, which allow it to penetrate the haze in Pluto's atmosphere. According to NASA, these images reveal new details about the dwarf planet's surface. Pluto was originally discovered on February 18, 1930, by Tombaugh at the Lowell Observatory in the United States. Prior to this, astronomer Percival Lowell had theorized the existence of a planet X, which he believed was affecting the orbits of Uranus and Neptune. Tombaugh's discovery was accepted by the American Astronomical Society, the Royal Astronomical Society of the United Kingdom, and the International Astronomical Union, IU, which officially named the object Pluto. Once considered the farthest planet in our solar system, Pluto's status was downgraded to that of a dwarf planet in 2006 by the IU. This change occurred because Pluto did not meet all three criteria required to be classified as a full-size planet. A planet must orbit the Sun, have enough mass to achieve hydrostatic equilibrium, a nearly round shape, and clear its orbit of other debris. Dwarf planets share some characteristics with planets, but fail to meet all the qualifications. Pluto has fascinated astronomers for decades. Since NASA's New Horizons probe flew by the planet in 2015, our understanding of this icy world has greatly improved. Recently, NASA shared stunning images of Pluto on its Instagram account, showcasing the small celestial body in a variety of vibrant colors. These images, which have captured the attention of many, reveal the complex and diverse surface of Pluto. However, the colors are not natural, but rather added by the space probe to highlight different regions of the planet. NASA's post describes Pluto's dramatic landscape, featuring jumbled mountains resembling those on Europa, networks of carved valleys, and ancient cratered terrains. The image, captured from a distance of 22,025 miles from Pluto, reveals the planet's heart, a massive glacier composed of nitrogen and methane. Pluto's surface is covered in ice made up of water, methane, and nitrogen, with a likely rocky core and the possibility of a deep ocean beneath. According to NASA, the surface is fractured and cratered, displaying shades of white, tan, and reddish-brown. In the image, the white and tan areas transition into the reddish-brown regions, and a partially visible heart shape appears in white at the top. NASA tweeted the image, captioning it, "Small planetary body Saturday." Taken by our New Horizons spacecraft from a distance of 22,025 miles. This image shows Pluto's true colors, including the heart of the dwarf planet, a Texas and Oklahoma-sized glacier made of nitrogen and methane. New Horizons, the first spacecraft to visit Pluto, captured the stunning view while orbiting the dwarf planet at a distance of 3.7 billion miles. Pluto itself spans slightly over 1,400 miles across, roughly half the width of the United States or two-thirds the width of Earth's moon. Its surface is blanketed with ice composed of water, methane, and nitrogen, and it may also contain a rocky core with a potential deep ocean. Another study has revealed intriguing insights into Pluto's past. Similar to Earth, Pluto experienced a dramatic shift, flipping on its side early in its history. Scientists are now working to determine the extent of this polar shift. Using the latitudes and longitudes of surface features for reference, they conducted a detailed investigation of Pluto's mass distribution and identified surface realignments, particularly around Sputnik Planitia, a heart-shaped feature on Pluto's surface. Oliver White, a New Horizons co-investigator from the SETI Institute in Mountain View, California, remarked, "In Pluto's current orientation, we're seeing signs of ancient landscapes that formed in places and ways we can't yet fully explain. We believe these features formed when Pluto was oriented differently earlier in its history and were later moved to their current location due to true polar wander." One unusual discovery from the flyby was the presence of large regions of jagged landforms near the edge of the hemisphere, which are believed to be entirely composed of methane ice. The team thinks that these bladed terrains are the result of Pluto's changing climate. Their appearance under specific conditions and in particular locations reveals how the surface responds to environmental changes. This discovery enhances our understanding of the processes that shape Pluto and other icy planets in our solar system, highlighting the complexity, dynamic nature, and diversity of planetary surfaces like Pluto's, noted Sean Mishra, a postdoctoral researcher and science team contributor at NASA's Jet Propulsion Laboratory in Pasadena, California. The findings suggest that these bladed terrains may be present in other regions of Pluto as well. The New Horizons team continues to analyze the data collected during the flyby, uncovering more mysteries about Pluto and the smaller worlds in our solar system. The mission is expected to keep providing valuable insights, possibly even revealing new information about Uranus and Neptune. The team is also in the process of selecting the next potential flyby target for New Horizons to explore and survey the outer heliosphere. Meanwhile, space telescopes continue to deliver stunning images of planets within our solar system. Recently, the James Webb Space Telescope, JWST, provided the sharpest image of Neptune in 30 years, offering a clear view of the ice planet and its rings. NASA scientists remarked that nothing like this has been seen since Voyager 2 became the first spacecraft to fly near Neptune in 1989. Neptune became the last planet in the solar system after Pluto was reclassified as a dwarf planet. It is 30 times farther from the Sun than Earth. Interestingly, Neptune is the only planet discovered through mathematical calculations rather than direct observation. With so much still unknown about Neptune, the recent photographs taken by the James Webb Space Telescope, JWST, are especially fascinating. Neptune is often depicted in blue in artwork and scientific illustrations, primarily due to the visible light images captured by the Hubble Space Telescope and the Voyager 2 spacecraft. These images show the planet as a rich, deep blue, which has led to its popular nickname, the Blue Giant. This distinctive color is a result of the planet's atmospheric composition, particularly the presence of methane gas. Methane is highly effective at absorbing red wavelengths of light from the sun, allowing blue light to scatter and dominate Neptune's appearance in the visible spectrum. However, the James Webb Space Telescope, JWST, has provided a completely different perspective on Neptune. Instead of visible light, Webb captures images in infrared wavelengths using its near-infrared camera, IRCam. Infrared observations reveal details that are often hidden in visible light images, allowing scientists to study Neptune in ways never seen before. In Webb's images, Neptune appears significantly lighter, with a more muted and ghostly appearance compared to the vibrant blue seen in Hubble and Voyager images. One of the most striking details revealed by Webb's observations is the presence of bright streaks and patches in Neptune's atmosphere. These are actually methane ice clouds, which reflect sunlight before it can be absorbed by the surrounding methane gas. The clouds form at high altitudes where temperatures are extremely low, allowing methane to condense into icy particles. These high-altitude clouds appear brighter in infrared because they reflect sunlight more effectively than the deeper layers of Neptune's atmosphere. By studying Neptune in infrared, astronomers gain new insights into its atmospheric composition, cloud dynamics, and seasonal changes. Webb's observations continue to enhance our understanding of this distant ice giant, shedding light on its complex and ever-changing weather patterns. One of the most striking features in the JWST images is Neptune's rings, which are prominently displayed. While Neptune's rings are not typically visible in most renderings, these new images confirm previous findings. Neptune's first ring was detected in 1968, but it wasn't until the Voyager 2 flyby that astronomers could confirm the existence of multiple rings. 3 decades later, JWST images clearly reveal Neptune's rings and faint dust bands.